Video presented to you by Unique to Billions e-learning. Please subscribe it and press the bell icon. We already discussed two tabular forms of representation of data, namely frequency distribution and grouped frequency distribution tables. In this video, we are going to study graphical representation of data, namely bar graphs, histogram of uniform width and of varying width, and frequency polygon. Bar graphs. Bar chart is a pictorial representation of data in which bars of uniform width are drawn with equal spacing between them on one axis. The heights of the bar depend on the values of its frequency, that is, how often that value occurs, which is taken on the other axis. Let us go back to the question of number of children in 75 families in a village. The observation in table format is as shown here. We are going to plot this data into a bar chart. Here we are going to take number of children in x-axis and families in y-axis. Plot bars on each data of number of children. So here we are having 0 children, 1, 2, 3, 4, 5, 6. Plot bars on each number of children. Height of the bar is proportional to the frequency. Here it is the number of families. The maximum is 28, so I can take a convenient scale 5, 10, 15, 20, 25 and 30. For 0 it is having 8, so the height will be like this. For 1 it is having 15, so I have to draw like this. For 2 it is having 28, so the bar will have a height this much. And for 3 it is having 12, so I have to draw like this. For 4 it is 7, I have to draw like this. And for 5 it is 4, and for 6 it is 1. So this is a bar chart of this data. From the graph, we can easily understand various details about the data. One problem with the bar chart or bar graph is that it is not suitable for continuous data. This is because in continuous data, data can take any value. So in this case, we need to draw bars for every number, which is a problem in this type of representation. In such cases, for continuous data, we are using histograms. So we are going to study now histograms. Histograms are similar to bar graphs, but it is used for continuous class intervals. Let us consider the problem of height of students in centimeters in a class of 60 students. The data is given in the table. Let us represent this data in a histogram. Here we are taking height of students in x-axis and number of students in y-axis and choose convenient scale for representation. Scale must be chosen to accommodate all data intervals. Here the data is not starting from 0, so mark a kink or break on the x-axis. Here histogram can be drawn easily by just drawing rectangular bars on width equal to the class size and length according to the frequencies of the corresponding class intervals. From 99.5 to 109.5 there are two number of students. So I had to draw bar like this. From 109.5 to 119.5 there are four number of students. So the bar will be like this. And from 119.5 to 129.5 there are 10 number of students. So the bar I can draw like this. From 129.5 to 139.5 there are 26 number of students. So I have to draw a bar like this. From 139.5 to 149.5 there are 13 students. So I have to draw a bar like this. And last 149.5 to 159.5 there are 5 students. So I have to draw like this. This type of representation is called histogram. In this graph there are no gaps between consecutive rectangles. The resultant graph appears like a solid figure. This is called histogram, which is a graphical representation of a grouped frequency distribution with continuous classes. Now consider a different case of this problem. We are just combining the first two and the last two classes. The data obtained is as follows. My class widths are different. So the first class is having a width of 20. Second is having 10. Third is having 10. Fourth is having 20. So my class width are different. If I just put height of bars proportional to the number of students, the graph will be like as shown here. The data is now observed to be not correct. You can just compare the two graphs we drawn for the same data. So the second graph is observed to be wrong. So here the width of bar is important. That is, in histogram class width is important. Here we have to take area of the rectangle selected should be proportional to the corresponding frequencies. We know area of rectangle is length into breadth. So if class width is equal, area is proportional to the length of bars. That is why in this case we take the length of bar or height of bar is proportional to the number of students, because here the class width are equal. We defined area is proportional to the frequency. We know area is equal to length into breadth. That is proportional to frequency. That is, length or height of the bar is proportional to frequency by breadth. What is breadth? Breadth is the class width. So I can write class width. So height is proportional to frequency divided by class width. In case of histogram, we call it as the frequency density. So height or length of the bar is proportional to frequency density. It is given by frequency divided by class width. Now we are going to do this correctly. For this, I require one more column in which I am going to calculate what will be the length or height of the bar. So, I am going to make it proportional to class width 10 for our example. To make it proportional to equal class width, just multiply the frequency density with the class width. So, if I just want to make it proportional to the class width of 10, then I have to multiply this frequency density with 10. Frequency density is frequency divided by class width. To make it proportional to class width of 10, I have to multiply with 10. The class width I choose here. So, here I can write frequency is equal to 6 divided by class width is 119.5 minus 99.5, it is 20 into 10, that is equal to 3. In the same way, here it is 10 divided by 10 into 10, that is equal to 10. In this case, it is equal to 26 divided by class width is 10 into proportional to class width of 10, that is equal to 26, and for this case it is 18 divided by class width is 20 into 10, that is equal to 9. So now we can draw the histogram with varying width. Similar to the previous cases, I have to take height of students in x-axis and number of students proportional to class width 10 in y-axis. Mark with the suitable scale, not started with 0, so mark a kink. Draw the bars corresponding to the number of students proportional to class width 10. So, from 99 to 119.5 it is 3. So, I have to draw like this. From 119.5 to 129.5 it is 10. From 129.5 to 139.5 it is 26. From 139.5 to 159.5 it is 9. So, this is a correct histogram for this data. Now, we are going to the last part of this video, that is frequency polygon. Frequency polygon is another graphical way of representing data as polygons. It is simply made by joining the midpoints of the upper sides of the adjacent rectangles of the histogram by means of line segments. For simply understanding this, consider again the problem of height of students in centimeters in a class of 60 students. The data is given here. I can draw the histogram for this data like this. Now, for drawing frequency polygon, just join the midpoints of the upper sides of the adjacent rectangles with lines. So, the midpoint of the upper side of this rectangle is this one, and for this, and for this rectangle here, and for this rectangle here, like that I can mark it. and just joining these points. Now there is one problem. My polygon is not complete. To make it complete, consider two classes with a 0 number of students in the beginning and at the end. That means in the data I have to consider 89.5 to 99.5. The number of students is 0. And the last I had to consider 159.5 to 169.5. The number of students is 0. Mark it in the graph. So here it will come 89.5 and here it is coming 169.5. And the number of students is 0. I have to mark the midpoint as here. And now I have to join the midpoints. Now I got a polygon which is marked in yellow color. This representation of data is frequency polygon. One main feature of this polygon is that area of the polygon is same as the area of the histogram. You can use the properties of conjugate triangles to prove it. Now, one problem arises here. How do we complete the polygon when there is no class preceding the first class? To understand it, just consider a histogram like this. The frequency polygon I can draw is like this. It is very easy to consider another class here. It is 70 and join to the upper midpoint, but there is no class preceding the first class. In this case, just consider a probable or imaginary class in the negative direction. Join the first end to this midpoint with the 0 frequency on the negative direction of the horizontal axis. Mark the point where this line segment meet the vertical axis. Remaining procedure as it is. Polygon with this point gives the frequency polygon. Polygon is marked in yellow color and shaded. Now, how to draw a frequency polygon without drawing histogram? If we know the midpoints of the class intervals of data, then it can be done easily. The midpoints of the class intervals are called class marks. Class mark is equal to lower limit plus upper limit divided by 2. So, mark these points with the corresponding heights proportional to class width. Join the points, we will get the frequency polygon. For an example, draw frequency polygon for the previous question without drawing histogram. We have the data. For doing this, we will add a column for class mark. Calculating the class mark first, then we will draw frequency polygon. Here, lower limit is 99.5, upper limit is 109.5 divided by 2, that is equal to 104.5. Here, we can calculate it as 114.5 and 124.5 like that. Now we can draw the frequency polygon. Considering two classes with a 0 number of students in the beginning and at the end finding the class mark for that classes also, we will get 94.5 and also 164.5 with a 0 number of students. Now joining the class marks and proportional to the number of students, first point is here, and for 104.5 the number of students is 2. For 114.5 the number of students is 4. For 124.5 the number of students is 10. For 134.5 the number of students is 26. For 144.5 the number of students is 13. For 154.5 the number of students is 5. And I can mark 164.5 at a 0 number. Now joining these points, I will get the frequency polygon. Frequency polygons are very useful for representing continuous data of very large size. Also, it is very useful for comparing two different sets of data of the same nature. For example, comparing the performance of two different sections of the same class. We will do problems of this section in another video. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.